Now we want to talk about skewness. Skew is how whether it's symmetric or not. Okay, so the formula is very simple. Okay, but calculation can be very complicated. But the idea is very closely related to standard deviation or variance. Right? Remember, variance is the square difference from the mean. Right? Average square difference from the mean. Okay. So this skewness is basically the average cubic distance from the mean. So you can see this is instead of raised to the power 2, raised to the power 3. So raised to the power 3, why we do that? Because if raised to the power 3, we can see how you can see the if 3 times, then if getting larger and larger, then we get bigger and bigger, right? Because multiply by 3, and then positive negative will not be cancelled out, right? So if it is above, more of them is above the mean than below the mean, right? Then the skew will be positive, right? And if if more data is further and further below the mean, right? Then it will be negative, right? Because it's scale up, right? And because remember the mean is in the center of all the data, right? Because it's average. Average is actually the distance between all the data. On average is 0, right? So and because usually we want to compare the data, the skew we don't want it to affected by how dispersed the data is. So that's why we scale it by the cubic of the standard deviation, right? By doing so, this skew has no unit. Okay, so that's why it avoid the problem of measurement or whatever, right? So the same as the coefficient of variation rate divided by its mean, right? So and then you replace this we call standard deviation by definition, so it will become a little bit more complicated formula. But the idea is very similar, right? It's like average cubic distance from the average cubic distance from the mean, and then you scale it by cubic of the standard deviation. So the most important part is the data, right? So it's the meaning, right? So if skew is 0, okay, so that's symmetric. In that case, usually what we mean is mean is same as median. Okay, that's nothing is tricky. Here we have skew positive. Okay, usually what we mean is right skewed, and here usually mean is bigger than median. Okay, and later you'll see the graphic what it means. If skew is negative, then it's left skewed. Mean is less than median. Okay, we'll see the graphic. But before we do so, we talk about some skewness sample counterpart, right? And remember, when you have variance and standard deviation, the sample counterpart is very simple, right? It's either multiplied by n over n plus 1 and a fraction. Here, same, we have some fraction adjustment, okay? So here we have adjustment is a little bit more complicated. It's a root of n times n plus 1, n minus 1 over n minus 2. So how to prove it? It will be more tricky. Then we need to calculate how we prove it. Is actually try to transform it. Okay, we can multiply this. Okay, and this gives you this fraction times this, right? Because this is definition of this, right? And we replace this, okay, by the sample, and then we give you n squared, and n squared n divided. This will be a estimate of the sample skewness. So basically, you replace the standard deviation, the population one, by sample one, and then you need to adjust a lot of things. Okay, this is the park, okay, or you use this formula. You need to adjust a lot to calculate the sample skewness. Okay, either use this or use that. So it's a little bit more trickier, the sample one. Then usually when you do software package, they give you the sample one. Okay, but you need to know what's the meaning of this, because by sample it can mean a lot of stuff, but you need to check the software to tell you what the sample skewness give you. So let's go to graphic. As we promised, what is this symmetric skewed, zero skewed symmetric one? Skew is, for example, a symmetric one would be a bell shape, mean and median more the same. Okay, in that case. And in this one, it's positive skew. In that case, mean is bigger than median. Okay, and the other case is left skews. Okay, so that would be a left skew. That would be a median bigger than mean. Okay, so that is how we talk about the skewness.